Hello, everyone, and welcome to our webinar. Thank you for tuning in today and joining us. Kinza, do you think we should meet for a couple of minutes for some more to join? Okay. All right, then we can begin. Hello everyone once again, and thank you for joining us today. My name is Pranita Roy, and I will be guiding you through the next 30 minutes of our e-drilling webinar. As some of you might be familiar with, we recently launched our advanced engineering tool, WellPlanner, as a microservice. Therefore, the subject of the matter today is how WellPlanner as a microservice brings value not only with its accurate modeling, but also improves the existing workflow. If you're at home office like me, grab a cup of coffee or tea and sit back while I introduce you to our hosts. So our hosts today are Kenza Lalu, who's the Chief Customer Success Officer at eDrilling and has over 14 years of experience in the oil industry from field operations to technical sales as well as project management. We also have with us Morten Svensson, who's the Chief Technology Officer at eDrilling and has experience in AI, predictive analytics, digital twin technologies in well construction, from optimizing drilling plans to real-time optimization. To get started, we have Kenza, who's going to address some of the common challenges that we face in the industry today and introduce our WellPlanner Microservices tool as a solution to some of these challenges. And to exemplify, we are to present some of cases in which WellPlanner Microservices was applied as a powerful engineering tool to enhance legacy solutions. This will be followed by a demonstration of eDrilling Open API specification presented by Morten, and then we are going to finally wrap up the webinar with a round of Q&A. So if you have any questions, please feel free to leave them in the chat box. We would also encourage you to download the WellPlanner Microservices product sheet from the event board on the top right corner of your screen. Over to you now, Kenza.
Yeah, thank you. Thank you very much, Juanita. So hi, everyone, and I hope all of you joining us today are doing well. And I guess just like us in eDrilling, most of you are also working from home and perhaps just like me, finding an office place in my kids' room. Before explaining what our solution is about, it is worth talking about why our customers needed this unique technology. Generally speaking, there are still today several challenges when it comes to well construction planning. And to list some of them, one is the long planning time required to plan a well. It often takes several months to plan a well when this time can be used to focus on having a safe operation and to deliver efficiency. Then the software is perhaps a legacy software, which could be not user-friendly, complex, but most importantly, not giving accurate outputs. And therefore, the risks and operational errors are increased, especially when it comes to drilling with tight margins. And these are just some examples amongst many. So now the question is, why many companies still continue with the same workflow and there is no change? And to answer this question, there are, of course, many factors you would agree with, I'm sure. One, it's very understandable that it's not easy to replace a system which your company had a big investment on. And then changing means also additional cost with the extra training, the cost of the new system, and so on. And then in addition to that, there is also a need for continuity and saving, especially in today's market. So at the same time, there is a need for implementing a more advanced solution to enhance drilling efficiency, increase performance, and maximize the results. And this is what we are doing today with our WellPlanner Microservices. So before talking about the benefit of our microservices, I would like to let Morten tell you more about our WellPlanner tool today and why do we have the world-leading models.
Thank you, Kenza. So the WellPlanner is an e-drilling application, or in this case, when we talk about microservice, a collection of microservices to perform advanced simulations for well planning and well optimization. In the desktop application, the user set up simulations or batches of simulations. These can be dynamic hydraulic and temperature simulations to engineer the hydraulic system for well or to optimize the drilling parameters prior to the operations. It's torque and drag evaluations, well control evaluations, and dynamic kick tolerance to find the safest casing shoe positions. So all this is now put out to a microservice. But if you go to the next slide, Kenza, we can also talk a bit about the difference by kind of using dynamic models versus using steady state models. So when it comes to the advantage, there is many, but let's look at some of the differences. Though not an advantage is that the dynamic simulations are more time consuming due to the modeling resolution. And in the same time, to achieve the accuracy you need, you also need to have better quality of the data. Since the models are physical, we need to configure the models with detailed data to make sure it actually simulates the models the well you are actually going to drill. But the first benefit by using a dynamic transient model as we use is that this simulation steps are always based on the previous steps. This means that all the transitions in parameters are affecting the simulations, compared to a steady state model where each calculation steps are fresh, which means that distribution of fluids, cuttings, and temperatures always correct. But in the steady state model, it assumes these properties are constant. The same goes for changes in operational parameters, where our steady state model will not be able to model the transitions. For example, when ramping the pumps, it will just assume in every calculation steps that the new flow rate is what has been used for the entire sections. So by achieving the accuracy of using dynamic transient models, you can reduce or have more realistic safety margins, which means that it makes it possible to drill wells that might not have been drillable earlier. Also, when coming to tight margin wells, you can also do a higher quality engineering to have better control of how to handle the risk associated with it. So, Kenza, back to you.
Thank you, Morten. So I will now talk more specifically about our WellPlanner Microservices. So it is based on a microservices architecture. It is a set of WellPlanner applications that can be run as software as a service or in a private cloud or also on-premise. And then it provides open APIs or interfaces for easier integration from customer software, web, mobile apps, or desktop applications. But also this is a very modern way of doing it and allows for dynamic scaling by running unlimited number of simultaneous simulations to define the best results. So in other words, it means that many engineers can run many simulations at the same time, at the opposite of a traditional application where you have one engineer doing one simulation at a time. So this makes the well construction engineering process much more efficient, and therefore it saves massively the engineer's time. Moving to the examples, this is an example of a client who decided to have the best well construction engineering tool possible. Some of the modules were developed internally, as you can see here. But when it comes to torque and drag and dynamic hydraulic and temperature, they have also chosen eDrilling for, again, the accuracy of our modeling, but also because we have modern technology based on open API specification, making it easier to integrate as external modules into their engineering platform. It has also, again, the advantage of being scalable solution, allowing many engineers to run these simulations at the same time. Now, while the first example is great, many companies, and for various reasons, need to continue to use legacy engineering solutions. However, as I mentioned before, these solutions can still be enhanced by adding into the workflow our WellPlanner Microservices. And because it can provide advanced and accurate results, the drilling plan is optimized, but most importantly, the uncertainties in well planning are eliminated, which means you have now better risk control of the operation. I would like to share with you now an example of a company who's making the entire well engineering workflow unique and, in my opinion, simply exceptional. So here, by also having our well sim in their workflow, the drill well on paper exercise becomes now a drill well in simulator, and therefore it becomes possible to prepare on the actual well to be drilled, to have better understanding of the downhole effects, but also better handling of well-specific challenges. There is also today the possibility to enhance the entire well construction process, from planning to preparation for the operation to the operation itself, where our digital twin can be used and enhance the performance in real time. So in real time operation, it enables to do forward simulation and what-if simulations to detect mismatch and give input to change the drilling plan, for example, or to avoid problems or change parameters for optimal drilling, or actually, in other words, just simply drilling the perfect well. So I will now unshare my screen and let you, Martin, show our open API. Our open API.
Thank you, Kenza. So now I hope you can see my screen. I just wanted to use a few minutes to show you a bit about our API. And as you see, we have made a web page where the API is available, and it's available to check the API and understand it, but also to test the API. If you look at the left side here, you can see we have an API overview. We have some API servers you can select, and there's also a part of authentication. And you also see the different microservices that we have available. So you have the dynamic hydraulic and temperature, torque and drag evaluations, steady state hydraulics, and also well control evaluation. We are going to look at dynamic hydraulic and temperature for this, and I will also run a simulation just to show how it actually works internally. So first of all of the units we use in the systems are SI units, so that is clear. First of all, we can do a few things. We can request a few things, but I think we just go to initiate a simulation. If I press here on model, you will actually see the entire schema to run a simulation. I can also use it, take a multi-line description, and as you see, we have the entire schema is presented. We start with the initial parameters, so the initial bit and well depth, and also some sensor positions. But we have the actual parameters like the time, the string speed, rotation, pump, fluids, and so on. And afterwards, it's also the well configuration, or the configuration of the models. So you have the trajectory, you have the tubular or the BHA. You also have the geometry, temperature profile, and also fluid data. I'm not going to go through details of all the different parameters it uses because it's available, so you can see it. But if I go up here and go to the example, I have a JSON file that is actually what is transferred to the API with a JSON file. And as you see, we have our initial bit depth and well depth. We have the sensor positions again, and so on. So, and I also already did the authentication, so I can just press try, and it will try to run the simulation. And it says it's initiated. I will copy my simulation ID, because that's the thing here. You connect to the microservice and ask it to do a simulation, and it returns, for example, the ID, and you need to use the ID to request other response from the simulation. So here I, for example, can then ask about the status, and it returns that its aggregation is ready, and so on. But you can also follow, if you have a long simulation, you can follow the progress along while it's running. There is also a way to delete the simulation. There's also a janitor in the microservice that is actually deleting all the simulations when they have been after a certain amount of time. So it doesn't store the data for you forever, but it allows you to take the data that you need. Then you can do the requests to get the results. So we have a function to get depth-based results, but we also have to get time-based results. So if I do a query for the depth-based, I will need to use the simulation ID that I already have. You can also set kind of at certain depth intervals you want to get the data. You can also, and then you have to select the different data types or data sets you want to get. In this case, for example, I can get my casing shoe ECD, for example. I could also ask for many at once, but in this example, I'll just ask for one and have a few things there. So then I can press try. And here it actually gives me the results back again. So here you see different ECDs at different depths that it actually returns to me. So, and remember, this is kind of a microservice, so this is not the user interface that anybody will be using. This is just to test the microservice. So in an implementation at the customer, they will integrate the microservice into their infrastructure. And that allows them being able to run simple or advanced hydraulic simulations in this case, but it could also be that you run large batches of simulations automatically. And that is one of the key benefits there, to be able to run a certain type of simulations in a certain way, so you always do it the same way in your system. This was actually what I was thinking about showing. So maybe back to you, Kenza.
Yes, just please, if you could share your screen, Morten.
Yeah. Yes. Now I did it.
Right. So yeah, just I want to add on top of what you have said, Morten, that this is also public and available to anyone. And then to access it, it can be we can provide it. Just a request, send us a request, so you can use our test environment. Now we will. Before moving to the Q&A, I would like to conclude by highlighting the benefits of our WellPlanner microservices. So it is based on Open API specification, which eases the integration of our token drag and dynamic hydraulic and temperature modules as external modules in your infrastructure. The core technology is based on advanced dynamic transient modeling and therefore gives accurate results, reducing the risks and uncertainties in planning. But it is also a modern and scalable solution, helping to have an efficient process and reduces the planning time. And then finally, using our WellPlanner microservices is also an opportunity to enhance your current system without having to replace it.
Thanks, Kenza. Thanks, Morten. We are now at the final stage of the webinar, and I can see that there are lots of questions waiting for us in the chat box. So I'm going to begin with the first one. It says, you mentioned torque and drag and also the hydraulic module. Does your WellPlanner microservices include other modules? Kenza, would you like to take this one?
Yes. So our WellPlanner microservices includes dynamic hydraulic and temperature module, and also which is available immediately. Our torque and drag module will be code complete end of February, which is very soon. But we do have also in our pipeline other modules. The next one will be to have the well control evaluation module.
All right. The next one says, thanks for the good presentation. What is needed from the company's side to start implementing this solution? Morten can maybe take this.
Yes, thank you. So basically, to get started, you could say it's as generally that you need a developer that can use the REST API and start implementing it. But of course, giving you a lot of value is to also then in that phase do some integrations towards other systems to be able to collect all the configuration data automatically. But it's a fairly straightforward job to do, because the API is very clear. It's also tested a lot, and it's also used by customers, so we kind of trust the API, and it's a very simple integration to do. Yeah.
All right, great. The next one says, how can these microservices help us to plan our wells better?
Yeah, maybe I can try to take this one, and Morten, you can maybe add if I'm missing anything on top of what I will say. So how can microservices help us to plan our wells better? I would say that one thing that is important to keep in mind is that this is a scalable solution. So it is run in a scalable environment, so we are able to run many more simulations at the same time. And this gives the benefit to also automate the process in your system and to avoid human errors, but also to then secure all the simulations to have very accurate results every time.
Yeah, I agree.
All right. The next one says, can the e-drilling microservices also be used for optimization during operation as well?
Yeah. So if you look at how we use the WellPlanner application, the normal one, we use our customers use it all the time during kind of different phases. So it's in the planning, but also during optimization or up to operation to do optimization simulations. And this would also go for the microservices. And it will actually make it more possible to automate these processes as well by using triggering automatically simulations during operations to, for example, find better parameters or explore different opportunities by using the advanced models that's available in the microservice.
Okay, all right. The next one says, we understand that using this as a microservice does not give us a user interface, but are there solutions available that provide a user interface for using the microservices? Can you provide this?
It's a question for you, Martin.
Yeah. So currently, eDrilling does not provide a user interface for the microservice itself. But as we know, have made kind of the microservice, and we are also working on a currently large project to revamp the user interface for our eDrilling platform. And in this project, we will be starting to provide the WellPlanner microservices within the platform. But there are a lot of kind of people or companies that does similar services. And there are a few ones that actually specialize in integrating microservices for customers. So that should be a solution to do.
Okay, the next one says, I guess these microservices are provided in a cloud. Is this in eDrilling cloud, or are we to use our own cloud?
Yeah, so that's a good question, and it's kind of really relevant. So eDrilling, we have a cloud that we use where we can provide the services to anybody. But we know that there are a lot of different IT strategies or security policies in different companies. So we also allow customers to deploy it in their own infrastructure. That means that we can offer kind of Docker images of the microservices to be deployed within your own infrastructure. It's a bit technical, but we use Kubernetes to orchestrate the microservices, but that could also be run on premise in an operating center. So we are very flexible in their needs and requirements.
All right. I think we have time for one more question. And it says, since this is implemented in a cloud environment, I'm wondering if this is secure.
You want me to answer that? Yeah. So security is a very kind of a top priority for eDrilling, and of course it needs to be, because we do a lot of our kind of deployment in the cloud environment. What I can say about that is we develop all our software and systems using the SDL framework, and we have a very high security focus in general. We follow the OWASP standards and so on. But the other thing is that also authentication of the users or the microservice is also done by an integration towards the customer's ID controller that makes sure that they can also control who has access to the microservice and who has access to anything. And what I also should say is that we regularly do external IT security checks. So we use external companies to perform testing of our security to make sure that we are at top level of that. So that is a very regularly thing that we do. So I'm not so sure about the security.
I think that's great. All right. I think that's all the time that we have for today. But for those of you whose questions we could not get to, we will reach out to you personally and respond. So don't worry about it. So before we log off for today, we would like to take this opportunity to invite all of you to our virtual booth this year at the SPE conference. We will be virtually present for the whole week, and we'll also be presenting a paper on our automatic drilling control technology. So we look forward to seeing you there, and you'll be receiving more information on this following the webinar. But if you can't wait until we get to you, please feel free to shoot any questions or queries at info@edrilling.no, and we look forward to hearing from you. Thank you once again for attending, and have a great day ahead. Thanks. Thank you again, Kenza and Morten.
Thank you.
Thank you.